going for it. And
Do we need help with anything?
All right, everybody. Thank you for coming to Wild AI. Clap once if you're with me. There we go. Clap twice if you're with me. There we go. Thank you, everybody, so much for coming out. As you know, Head Flyer is transitioning to Dangerous Man. So in the interim, the improving team, mainly Emily here, has been so gracious to give us the space to come and congregate. So please give them a nice warm round of applause. Thank you so much for improving. Really quickly, the feng shui is a little weird. We have this screen over here to have some links to the speakers for their LinkedIn. But I have to be here with the mic because the reception is a little spotty. So just note that. But anyways, without further ado, we're excited to have everybody here. And our first speaker tonight is going to be Kaushik. He recently just got endorsed by Mayo Clinic for some awesome work that he's doing in kidney disease modeling. And without further ado, I'll welcome on up to here. Thank you.
Hey guys, good to see you here, and thank you for having me. Thank you, Wild AI team, for that.
You're good.
I'm good?
Yeah.
Okay, thank you, Wild AI team, for having me here. It's a pleasure to be here, first of all, to meet like folks who are into AI who are also deeply technical. So, just to give you a heads up, I'm a CEO, so I'm not too much of a technical person, but I'll try to keep it a little bit technical as possible. So my startup is Canary AI, and so we started this company like 5 years back in India, and we were initially focused on hardware, and we started out building a point-of-care device for kidney testing. So it's like a device that is in the patient's hands that takes the blood of the patients, and it gives you measures like for your kidney function, like creatinine, electrolytes, and other functions. And 3 years of R&D. That one failed. It tanked. So we kind of tested with like serum and something like that. But once we went to blood, things got really messy, and we couldn't sustain the operations. And then that's when I looked into the space. That's when. That's good. Yeah. So that's when I looked into kidney. That's when I deep dived into other opportunities in kidney care. There's some problems. There was one problem which really struck me. Readmission rates in kidney care are one of the highest in healthcare. It's at a staggering 30-40% in the US. So that was a bit of an interesting thing for me, because I was working in kidney care, and this could be one opportunity that I could really go into. And that's when I found out one of the key reasons is patients have a lot of fluid buildup in the chest, and sometimes their electrolytes really shoot up, and sometimes they really do have a cardiovascular arrhythmia event. So this was an opportunity that I was really thinking about, and being a hardware engineer, of course, I did have some training in software as well, but being a hardware engineer, this was something that was in my zone. So I took it up, and I started building a wearable device that can be put on a patient's chest, and it can monitor key signals, the impedance across the chest, so that you can model the fluid levels and measure ECG, and with ECG you can not only assess the cardiac function, but also we were able to predict hyperkalemia events, which is rise in potential. And that's when I met one of my best friends. So I went one of my best friends, and I told him about my idea, and he asked me one question. Hey, all that's cool, man, that's really cool, but what's your AI vision about this idea? What's your AI vision, right? And that's the question he asked me. And that's the question he asked me, what's my AI vision about this idea? And that was pretty interesting, and that got me thinking, hey, why didn't I think of this 6 months back? This is a readmissions problem, okay? There's a lot of data on which patients are coming today, which patients are coming within the next 30 days. And that's when I started thinking, okay, what best can be done, right? What could be done to predict readmissions early on? That's what we are doing with the device, and how can we make it better? How can we make the prediction better? That was my fundamental question. And that's when I started digging into public health data sets given out by Mimic, which is one of MIT's Beth Israel Hospital's data sets. And I started crunching data, and I found out that, hey, I mean, the readmission rates are like 40%. And when it comes to like transplant or dialysis, it's really worse. And patients, even before dialysis, they have like 30-35% readmission rates. So just to give you some context, a readmission is an event which, once a patient goes to a hospital due to any event, and they come back within the next 30 days or 60 days, and that's what a readmission event is. So I was looking at ways to like predict it. What are going to be the key signals that can help me like predict this readmission events? Can everyone hear me across the hall? Okay. So what are the key signals that will help me like predict, that there is going to be a readmission event, right? So it turns out that we narrowed it into like 5-6 clinical categories. Like it could be like, again, as I mentioned, it could be like a fluid buildup, or it could be like, high potassium levels. It could be like cardiovascular issues. It could be like, an infection issue, and a ton of other issues depending on the patient. So now this becomes a data problem, right? So how do I predict all these events, right? Because this spans data, not only a one dimension, or not only a data of one category, but it involves data from like, vital signs, data from like labs, like your blood labs, which are mostly in text, by the way. And then like it requires waveform data, like, your ECG levels or your pulse oximetry levels, and a lot of BP data as well. BP data is like, in remotely, it's like given, it's like you have one spot measurement data. But in the hospital, you would have an invasive blood pressure measurement, which is more like a continuous data, so which is like a waveform again. And then there's a plethora of images, pathology images, which have details on the biopsy levels. And then like you do have images from the ultrasound scans and from the radiology scans, or like chest X-ray levels. That gives you a lot of context about a patient's status, right? So we were like crunching through all this data and trying to make sense out of it. And the first thing we said, hey, let's tone it down. Let's not taking too much inputs. Let's just build with what we have. And so we were looking in like structured data first. We looked at vitals. We looked at we looked at labs. We looked at the diagnosis codes, like what are the patients going to be diagnosed? What kind of conditions do they have? Do they have like a cardiovascular issue? Do they have like a history of hypertension? Do they have cancer? In some cases, a lot of patients show up with cancer. And what are going to be like the comorbidities? We took that data, and then there was some more. We took more inputs about what's the medications that these patients are on, and what was the previous admission like, because that's going to signal a lot of things, right? When we looked at issues like fluid overload, it really mattered like what is going to be like the input fluids and output fluids, right? Because an excess of that might be a good predictor for fluid overload. So we combined all this inputs first, and then featured engineered some to like more like a 24-hour slope or like 48-hour slope, depending on like the time of length of stay. With some features, we took a longer trajectory. We kind of looked at how the patient has been progressing, not only during this admission, but in the previous admission. So there was some feature engineering involved, heavy feature engineering involved with some metrics. And we, initially we used like gradient boosting for like a good estimation of what is going to be the risk of readmission. For obvious reasons, right? Gradient boosting is used all across finance and banking sectors, and it's one of the stable, safe risk models. And that's something you need in healthcare. You need like stable, safe risk models that can take in multiple multi-parameter inputs and give out a non-linear prediction score. So that's the very simple crux of it. And that's when, again, my best friend, that's where he comes in, because he has quant finance background, and previously he was building like risk models, stable risk models for like trading and understanding if a stock is going to go up or and when to like buy in and exit. So that's when this inputs came in, and we built a prediction model. After all these efforts, what was the accuracy? What was the ROC? 0.7. 0.7 is just like a little bit better than what a human could say. A human could say with 0.5, maybe 0.6, but 0.7, that's it. So that's when I asked, what am I missing, right? What am I missing? I've put in all the data into structured information. I put it into a risk model, and still it's getting 0.7. No, that's bad. And that's when I realized a lot of this patient context is not in the structured data everywhere. It is in the unstructured notes, right? So every hospital, I mean, I don't know, I've never been admitted here, but I've seen the data. So I don't know if you get like, I don't know if you get like a text of like, you know, your discharge summary. I don't know if patients get it, but that has a ton of clinical information. That's when I looked into Mimic and I said, hey, you have discharge summaries. We could do something with this. This is a lot of unstructured language. There's a lot of context. Every discharge summary is going to be different from each other. There was one discharge summary that says, oh, these are the patient's vitals, these are the labs during admission and discharge, and we have been putting the patient on these many medications. They had a history of cancer, they had a history of bleeding in the gastrointestinal area. So these are some of the context that you get. And each and every discharge summary is like different. So I cannot like look at it in a static way and say, hey, we are going to like extract 20 features from a discharge summary. That's not how it works, because every discharge summary is different even for the same kind of admission. So that's when we kind of looked at clinical bidirectional encoder transformer models. So we looked at models like Clinical BERT that could really go through the chunk and can kind of like break down the clinical summary into embeddings, and which can later on make a context of a sentence or 2-3 sentences depending on how much you chunk it together. So that's when it became more meaningful, right? Signals became more meaningful, and that's when we took in a lot of the unstructured notes, put it in our BERT models, and we built two things. We built this risk model, gradient boosting. We fed the inputs that we got from the Clinical BERT, like probably 50-60 parameters into the model, and the accuracy improved to like 0.8 or something. Yeah, 0.1. That's like a big deal, like 10% improvement. And that wasn't enough. Like we kind of wanted to go a little more deeper. We wanted to see how we could make it work as a transformer model itself, right? And that's when we use the same like BERT as a transformer, not just to like create the embedding and fetch as a parameter to the XGBoost model, but just as a transformer itself, how good is it during the prediction, right? And that's one of the things that we were thinking about, and that's when like we got into Mayo Clinic's Accelerate program, because they like came to India, and we said, hey, we don't have a model yet, but these are some things that we would love to do, and now we're seeing a ton of like data in Mayo Clinic. So I think that's where we are right now. We are like looking at a lot more data, a lot more unstructured notes, a lot more structured fields, and I think there is a good future for us to evolve from this place to making it more multimodal, because like we do have access to biopsy images, pathology images, which can be very valuable for like transplant use cases and identifying, okay, what's this patient's etiology going to be, which is a key prediction factor. So I think, I think one of the key angles here, purely from a modeling perspective, is that understanding the clinical signals, understanding the medicine itself is going to be one of the most crucial things. Because from a modeling perspective, if the right data doesn't get through, you're not going to have good predictions, right? So that is one key context for me. So so that's where I am right now, trying to like build a multimodal AI platform with like image encoding, waveform encoding, and then the text encoding, looking at the structured data, trying to build out a prediction score. Still figuring out, should it be like a purely textual embedding model? Should it be something more like a structured model in place, the final prediction engine? But yeah, I hope we are getting there, like trying to iterate and all of that. So thank you for your time.
Thank you, Kaushik. We're at time, so I don't have time for questions, but clearly he's doing some awesome work, got recruited to Mayo all the way from India. If there's anything that you can do to help support his work and his platform and the research that he's doing, please don't hesitate to reach out and touch base with him after this. But moving on, the next speaker that we're going to have up here is Joe LaChance. Funny enough, I just went out to San Francisco on a whim, and I went to a big trade show where all these startups were pitching their ideas. And I stumbled across Joe all the way out in San Francisco. And he was being mobbed because he was working on a really important problem, driving down token usage in models. And as you know, especially with these agentic frameworks, token consumption is a huge cost factor that keeps people from really unleashing and using them. So he is working in that direction. So please welcome Joe.
Hey, it's good to see everybody. I probably made a huge mistake because in coming here, I realized how many technical people there are here. I'm not actually talking about anything technical tonight. I'm working with developer tools and AI though, so if you guys have questions, if you guys want to dig into that, come at me, like I want to talk about it. Last time I was at Wild AI was probably 8 months ago, I hate to say it, and the audience was very split. I think it was maybe even 20% technical, maybe 80% people just checking it out, seeing what the heck's going on. So what I was going to talk about tonight was the founder journey. So like Jake said, we met in San Francisco on a whim in the middle of February when most of you were probably in your homes staying warm. It was really interesting. It was this Accelerators demo day, which was basically a science fair. So I had like the trifold cardboard and everything, tons of people. But in going out there, it was super interesting. It was a ton of fun. I met a ton of founders, and he mentioned at that time, he said, hey, do you want to talk to Wild AI? And at that time I said, yeah, absolutely. Like, why not? Why wouldn't I want to talk to Wild AI? But in the back of my head, I'm like, I have nothing to talk about. I don't have anything to tell you guys. So it took me a while to like figure out what to talk about. And I realized I kind of kept coming back to the founder journey. I wanted to talk about, while I'm working on AI, all of the things I have to do in order to be even remotely successful at that. And some of the steps that you can use to replicate that. Maybe if you're a founder, some of the things that you have to do, or maybe you're getting stuck on some of these steps in order to move forward. And so, two stories to start off. First story, about a year ago is when I started my founder journey. It was, I suppose it was in about February. And at the time I decided I need to find a mentor. I don't know what the fuck I'm doing. I should probably find somebody who knows what's going on. So I reached out to this guy. He is a founder himself. He's somebody who's helping other founders get their feet, get on their feet. Get an intro call with this guy, sit down and talk to him, super nice. Explain to him my situation. Hey, I'm brand new, what do I do? And he goes, I have no idea what you should be doing. And I'm like, whoa, what's up with that? Like, you should know what I'm supposed to be doing. Like, I need help. That's why we're on this call, right? He goes, I don't know what you should be doing. But I do know that you're the only person who knows exactly what you're supposed to do. I don't know what you're supposed to do, but you do. And I got off the call, I was confused, a little upset. And after maybe a day or two, I realized he was right. I'm the only person who knows what to do. There's nobody else who knows how to go on this journey except for me. And so you kind of have to go with your gut. You have to believe in yourself. So that's the first step. That's like the first, it's the first of 4 steps I'll talk about tonight, believing in yourself. There's another story I'll talk about. I think about this one a lot. This one's interesting. Steven Spielberg. So he did not get into USC. He applied to USC 3 times, did not get in. Applied to UCLA, did not get in. Okay? This was for film school. This is Steven Spielberg. Did not get into film school. It's because his grades were bad. He did not get into school. What he did instead, he shows up to Universal Studios and he takes the tram tour, which is like the, whatever you crawl on the golf cart and they take you around, right? He jumps off at the sound stages where they're filming stuff. He goes and gets a day pass for the next day, finds somebody, talks him into it. He comes back the next day, he's wearing a suit, he's got a briefcase, he's got his lunch. Not what normal people do with a day pass, right? Shows back up. So he's gonna pretend to work. He goes and finds an empty office. So he goes back to Universal Studios. This guy goes and sits in an empty office and he pretends to work. And then he does it the next day. And then he shows up the day after that and does it again. And he keeps going back to pretend to work at Universal Studios. Talk about a guy who believes in himself. That's pretty bold. the next step, and these are things I've thought about over the past year. These 4 steps. These are things I've continue to come back to and remind myself of. Believe in myself. The second one is creating a vision. In creating a vision, you have to be very specific with what you want to create. So, let's say we want to go to Mars. We've all decided to start a company, we're all going to go to Mars. We need to have a pretty specific vision in order to do that, right? Like that's going to be complex at best. But the more specific the vision we can create, the better, right? We can, I don't know, figure out what our rocket's going to look like, figure out all the parts that we're going to put in our rocket, figure out what it's going to smell like, what the food's going to taste like, how long it's going to take to get there. Obviously, that's a very big problem. It's probably a bad example. But you need that. You need as much information as you can in order to create a vision. Once you have a vision, step 2 is changing your behavior. You have to start acting like that vision exists right now. Not you want it to exist, it literally exists right now in the present moment. And that's weird. That can be awkward for people. That can be weird to think about. If you're starting a company, if you're creating something new, to believe that it exists when it doesn't exist yet. And you're the only person with that vision. Nobody else has that vision. It's hard. It's scary, even. And that takes me to step 3. The third thing you need is to be delusional. So you need to believe in yourself, you need a vision, and you need to be a little bit delusional. Actually, that's a lie. You need to be a lot delusional because you're the only one with that vision, right? No one else has that. You need to believe it so deeply that you can carry yourself through to the final step, which I've called the valley. And that's what it takes for reality to catch up with your vision. And so the more delusion you have, you can get yourself all the way till that becomes reality. And back to Spielberg for a second. He had all of those, right? He believed in himself. He created a vision. He had an idea in his head he wanted to be a director. So that crazy guy goes to Universal Studios and just starts working for, I literally have no idea what he was doing for those days. I am genuinely curious. He was completely delusional. And it's interesting in retrospect, if you think about it, if you think about that in retrospect, he was hyper successful, right? So if you squint a little bit, it looks like confidence. It looks like if you show up to Universal Studios and you just start working, you know what you're doing, but that was delusion. He was delusional. You guys actually might know some people. This is an example, and no shade on anyone. This is something that I've done too, where you show up and you say, hey, I've got a great idea. I need an engineer to complete this. By the way, will you work for Equity? Maybe you've done this, I'm sure you've heard somebody ask you this. That's normal. Those people are delusional. That's okay, they're trying to get their vision to where they're gonna end. That's really about it. I mean, I think the last thing I'll leave you with is whatever you envision, whatever you want to create, just make sure it's very specific. Make sure it's exactly what you want. The last thing I think about a lot is just be careful what you ask for. You might just get it, right?
What's your product? My
product? Yeah, I'm making, it's a context management tool for AI. Yeah, so you can think, if people know what Docker is, it's essentially like it's not a Docker image, but it is an analog to a Docker image. You can put any data you want inside of that, you can query that. It runs locally.
Context engineering.
Yes.
And tokenomics.
Yes. Yeah, this works completely locally. It works offline. You can push this to the cloud. It runs. It includes a database. It includes an LLM. It's completely open source. It's free. If you guys want to make your AI models a little bit more accurate, come talk to me. If you guys are trying to combine data with AI, come talk to me. I want to help you guys out.
All right. Joe, you got 1 more minute. Does anybody else have 1 more question for Joe? Anybody? Okay, that's okay.
I understand.
Sure.
I just put on my spacesuit. I go to SpaceX, find an empty space. That is how I will achieve my dream of being the first person to walk on Mars.
I would absolutely love to hear you doing that. Yeah.
All right, thanks, Joe. Thank you so much. All right, speaking of technical people who are really great speakers, our last speaker tonight is going to be Mohamed Akone. He reached out to me about a problem that he saw that I agree. There's not a lot of activity in town, specifically with agentic harnesses like OpenClaw, and Mohamed has a unique perspective where he is a very vetted cybersecurity professional and engineer, and can probably see all the threats in some of these harnesses as good as probably Mythos at this point. But he was really passionate about how this is really being overlooked here locally, and I wanted to give him a chance to speak about it. So please welcome Mohamed.
How are you doing today?
Good.
All right. I don't have a company to pitch to you guys.
Maybe just after this.
Has any one of you guys here that's overwhelmed every morning with your emails of AI everywhere, left and right, your inbox? Anybody here?
Yeah.
I'm a very curious human being since I was little. And I'm socially wild. So at the age of 12, I share a room with 4 of my cousins, or 3 of them, including me. So do you guys know those bumpers in college?
Right,
Now, can you imagine now? It was loud. Now I was the oldest, which meant in my culture, you have to take care of your siblings. So I joke with my parents, I was like, man, you guys robbed me away from my childhood. I have to take them to school, I have to change their diapers. So I'm socially wired. Everything that I do evolves around how can I help people. So my work sits at the intersection of tech, community, and education. Tech, I've been in cybersecurity for over 10 years now. I used to work in Silicon Valley. I used to teach here at University of Minnesota. I've been mentoring since I was little. I also have an organization called We Network now. We provide professional development and mentorship. And why am I telling you guys all of this? Because I've been blamed that, why are you doing all this work, you're not getting paid? Like I created an organization, literally, when I got into cybersecurity, I was like, this is not rocket science. Anyone can do this. As long as you have courage, like he said, you believe in yourself, you can do this. And I created an organization just for that. Okay, now I'm telling you all of this because I was overwhelmed 7 years ago. I have an organization, I have my 9 to 5, my inbox is flooding. So what did I do? I hire an assistant. And I have to onboard the assistant. Then there's a back and forth. We say, hey, I reach out to this speaker, if you were getting a speaker to speak at my organization, but he or she said this, what do you want me to tell them? So there was a back and forth, you know. Fast forward, a year ago, I took a program at MIT. You know, I wanted to learn more about AI. It was a 3-month program. It was in the summer in Minnesota. Now, thinking that I'm crazy, who actually gave up their summer in Minnesota? So it was on Saturday and Sunday. That was me. So I learned about this cool stuff, you know, Transformer, CNN, RON, you know, context windows. It was really cool, like being, you know, in the class with these virtual class with these smart people. But it was not cool. So I got to use like open sources like RapidMiner, 9 and all of that. But it was not really cool. It couldn't really do what I wanted to do. Then at the beginning of this year, I came across something. Maybe you guys are heard of it. It's called OpenClaw. Oh boy. I wish I would have met you, Joe, earlier because I've been burning on tokens, hundreds of them. If I remember. So, came across Claw. Remember I told you guys that I was in this MIT class that took me to another group, that took me to another WhatsApp group, that took me to another Slack group, and yeah, over the valley. So I built my own agent, and I have 6 employees that work for me. They don't take any breaks. They know what I want. I wake up in the morning, I have my executive brief at 9 a.m. I have my email brief. it tells me what is important on my calendar, and it blew my mind. So I just don't want to get technical for you guys here, but I used different models. It was first Claude.
Get technical.
Okay, it was Claude that I was using as one of, okay, let me make it simple here. So AI agent, basically the definition is LLM plus harness equal agentic. That's it. That's the definition of it. Agent in itself is nothing. So I've been using LLM model like Minimax, Cloud, and now it was a Cloud that got kicked off on Opera 16. We couldn't use the subscription. That's way to open AI. But I have an agent that's chief of staff. I have an agent that takes care of my organizations, what I have going on. I have an agent for my family. So it knows what I need to pick up my daughter. It knows that what activity is going on in the city. It will tell me. I have an agent, it's so go is security to make sure to check on the work of all the other agents. I have another agent to give me to do a market research for me for all the work that I'm doing. Now I'm going to show you. I'm going to read you guys something here. Okay, when I set it up, I was like, hey, I give it a name. His name is Don Pape. Since you are my chief of staff, will this sub-agent be reporting to you or me? It goes, recommendation, they should report to me first and I'll report to you. Best structure, you are the principal, me, chief of staff, and then it goes and it gives all the description of who does what. And then the security, they will do discussion among themselves before it gets to me. Okay, so a couple of days ago, one of my, so in OpenAI you have cron jobs, you have Heartbeat. Heartbeats wake up every 30 minutes to see if there isn't a job going on. Cron job are scheduled jobs, basically. They say, hey, give me a brief every morning at 7 a.m. about what's on my calendar, what's going on in the AI space. So this time around, a few days ago, it failed. Now, this is the magic. I didn't do anything. It went, it fixes itself in less than 30 seconds. It goes, the cron job are still failing. Isolated section cannot reach the OpenAI because I'm using OpenAI. I couldn't use Cloud anymore because of they got away from the subscription. From inside the container, let me check the container DNS. It goes, let me test the OpenAI API directly. And then it goes, let me switch the morning brief to run in the main section instead of isolated. Wait, the system event test is too brief for the main section to run a full briefing. Let me fix that. Within 30 seconds, less than it was able to fix that and bring me what I needed. Now, do you guys remember earlier I said that I'm socially wired. Everything that I do, I serve on the board from K-12 to the University of Minnesota to a cybersecurity summit. Everything that I do because I was wired that way. So I was like, okay, how do I bring this information to people? A few weeks ago, I'm part of this group. We are baby boomers, we are Gen Z. We talk about everything from politics to music. And I was talking about Open Cloud. And I'm very excited, as you can see, I'm a very excited, passionate person. And I was excited talking about this, and the room was quiet. And I catch myself. They were rolling their eyes because it was too good to be true. Now you're asking my assistant, no, I have not fired her yet. Yeah, she still has a job because she's still good at something. But all I'm trying to do is tell you here that Justin Wang, the CEO of NVIDIA, once said, I think it was March, that every company should have an open cloud strategy. I would say every professional, every person should have an agentic strategy. Because this thing, my friends, is here to stay. It's not going anywhere. He also said, this open source achieved in a few weeks what Linux, it took Linux 30 years to achieve. That goes to tell you that this thing is here to stay. So, I talked to Jake, which is a great person. I was like, hey, Jake, how do we bring this information? Because I'm in these rooms, I kid you not, every day in Slack, somebody has something great going on. It's like, hey, this is a Zoom link. Anyone want to jump in? And if you have time, you jump in and we just jam in. But when I leave my house, I don't see that. And Minneapolis is a very vibrant, tech community. But I was like, why are we not talking about AI? So that's why I'm here. So we can get this conversation started. Hopefully, it's you guys will have your AI, the agentic AI strategy. So if you have any questions, I'm here.
We got a minute. Do we have a question or two?
Yes.
What does it cost you to run that every month?
Every month, so when I started, I've been maybe close to $700 because I was novice. So I was using API tokens in here, right and left. Okay, now let me get technical. So what I did, so I have different AI models, right? I have OpenCloud, I have OpenAI, I have Minimax, I have Brave. So depending on the task, it uses the different model. Also, I have a model that's a fallback, meaning that let's say OpenAI decided that, hey, we're not using subscription anymore. At least I can talk to it. So there's a fallback. I think I use Llama, one of those non-premium, to fallback as a fallback model. So if there's a web search, it uses Brave to go do the web search. So it doesn't need to use OpenAI subscription for that. So, but that came with time though. As I was learning, I was burning to money, because okay. So anyways, a learning lesson, yeah. But it's addictive. And one last thing that I have to tell you that I'm very, so my mom was here a couple of weeks ago for spring break. So where I lived is a 3 steps levels. At the bottom I have my office. So I've been sitting in that office all day long. At night it's time for my daughter to go to bed. I hear my daughter and my mom talking, negotiating. So my daughter goes, hey, you can tell Papa that I can go out there at night. She goes at 8. You can tell Papa. And my mom says, no, Papa's gonna be mad. And my daughter goes, but he's your son. Right? I could hear that, I was like, she's 8 years ago. So anyway, after the negotiation, all of that, she ended up going to bed. And then I was stay at my desk at 9, my mom comes, into my office and she goes, hey, your daughter, and I went to bed. At that moment, I'm saying my daughter is 8, I'm thinking about, like I'm sure what's gonna be life for my daughter? And I'm also thinking about my mom who's in her 50s, which is not computer literate. Now this excitement plus this, I don't know how to explain it. Now, I speak multiple languages, even French. I don't know how I felt at that moment. Excitement, worry, but yeah, I thought I would share with you. So yeah.
All right, well, thank you. Thank you, Monty. I always love the opportunity to hear you speak. And thank you to our other speakers tonight, too. And again, thank you for all of you for coming. During transition, it's hard to get and retain people from churning on from groups, and I'm just so thankful that everybody came out tonight. We'll be back here again next month. Now that we've gotten a little bit used to the space, we can create the feng shui maybe a little bit more, maybe use some resources that they have here to do a different type of event. So stay tuned for that. June is the month that we plan to be back at Headflyer, but that is now called Dangerous Man, which I think pairs very well with Wild AI. So we'll be very excited for that. I'll be very public and we'll make announcements. But again, thank you so much for this community. Wouldn't be a community without any of you. So I just want to say thank you for coming and bringing your enthusiasm. And like Mamadi said, let's continue to build momentum around these ideas here and start spreading what is possible with this new technology and use our vantage point to help liaison what's viable and useful to the rest of everybody else here in our community. So thanks for being a part of it. We have to be out of here by 8 p.m. Taberna is across the street. So if you want to keep conversations going, feel free to move over there. And again, thank you so much for coming. Appreciate you all.
What do we What do you